Welcome everyone. My name is Tadeusz Daszczyński and I'm working in Warsaw University of Technology in Electrical Power Engineering Institute. Today I'm going to present you my article about construction and evaluation of a lab stand for testing medium voltage switchgear using virtual reality. The presentation plan is shown on the slide. Let me start with a short introduction on the use of virtual reality technology in the power industry. Next, I will briefly characterize a model object in the form of an medium voltage switchgear. Then I will tell you what it looked like and what elements the application consisted of and about its tests. I will present the summary in the form of a future work uh, in our laboratory.
The concept of VR technology was first introduced in 1989 by the American programmer Jaron Lanier, the founder of VPL Research, in order to name a computer-simulated three-dimensional environment modeled on reality. VR technology has gained its application in many areas of everyday life and in many branches of modern technology. Computer modeling of power systems and devices is today an integral part of the work of modern engineers. The mapping of devices in the digital space enables many often difficult logistic operations to be carried out in a convenient and economical way. For example, a transformer or switchgear consists of many individual components that take a lot of time and money to make. These elements are then transported from many other distant locations in order to assemble them into one desired power device. The final effect of assembling such components translates into the considerable size of the devices, which is associated with many difficulties. The transport of power equipment is a serious undertaking that involves high costs and the involvement of many people. In the proper functioning of the power system, physical devices that play the role of generation, distribution, transmission, or even protection cannot be omitted, while for purely didactic purposes the undertaking of creating and transporting the device may turn out to be an extremely expensive procedure. The main aspect of the VR application that was used for the purposes of the work is the virtual model of the medium voltage switchgear. A switchgear is a set of power devices operating under the same rated voltage used to distribute electricity. It consists of a structured equipment with busbars and insulating elements, as well as power apparatus that performs a switching, protection, or measuring role. The medium voltage switchgear implemented in the application is based on the real model of a switchgear manufactured by Electrometal Energetyka S.A. The described switchgear has been developed in a four-compartment version. Each compartment is equipped with a different type of devices adapted to the purpose of a given compartment. The set switchgear contains four divided areas which include busbar compartment, control circuits compartment, withdrawable module compartment, and cable compartment. For the proper functioning of the VR application, a set of necessary devices was used which included virtual reality glasses, two touch controllers, power supply, and charging cable included in the Oculus Quest 2 set. A computer equipped with a modern processor and graphic card with, of course, sufficient computer power, and monitor displaying a view from the perspective of a person using VR glasses used to analyze the movements of the respondent in the real time, and USB cable Type-C connecting the glasses with the computer unit in order to transmit the image to the monitor and increase the computing power of the glasses. After starting the VR application, the user will see a menu on the screen on the glasses with a selection of a specific part of the exercise. The choice is made using the main button pointing to the selected option with the indicator generated by the controller. The first time you encounter the program, the target option will be to select Tutorial first. The user has a choice of exercises, learning how the switchgear is built and the possibilities of diagnostics based on visual inspection. In the first part of the exercise, the user was presented with the construction of the medium voltage switchgear on the example of the E-square alpha switchgear. The user of the application will get acquainted with the basic structural elements of the switchgear, see the devices included in it, read the information prepared about them, and view the construction diagrams displayed on the virtual board. After examining a given element, press the return button on the wall, which results in the going back to the practice field and deselecting the examined element on the list of the elements of the wall. In addition, on one of the walls of the virtual room, there is a board containing diagrams of devices and elements used in the exercise. In the second exercise, entitled "Diagnosis of the switchgear", the user had the use had to use a trolley to pull out the medium voltage circuit breaker located in the withdrawable compartment of the switchgear. Then he was tasked with finding five damages of the medium voltage switchgear and its components caused by the action of the electric arc. In order to open the withdrawable compartment of the switchgear, it was first necessary to release the lock preventing the opening of the compartment door in the absence of safe conditions. This is done by opening the circuit breaker contacts, by pressing the red button responsible for controlling the circuit breaker, and closing the earthing switch by means of the green earthing switch control button. In the event of taking incorrect steps, the user will be notified of the inability to perform them. In order to test the VR application, a group of 43 students of electrical and related faculties were gathered. Before the VR application test, each student was familiarized with the construction of real medium voltage switchgear located at the test site in order to later verify the correctness of the switchgear implementation in the virtual environment. Then, each of the students proceeded to perform the previously discussed application program and then convey their feelings from the virtual exercise by completing the prepared evaluation questionnaire. The answers of the participants of the test confirmed the belief in the attractiveness of VR technology in the academic environment. According to the tested, the exercises prepared in VR allowed for effective memorization of the presented content about the switchgear and its components, which confirmed the sense of using VR as a way of supplemented standard teaching techniques. The models implemented in the VR application have been recreated realistically enough to ensure the positive reception of the application among the responders. The overall VR exercise was received positively by the test participants, and they strongly recommended the attractiveness of the presented exercises and the possibilities created by virtual reality. The author of this presentation managed to obtain a grant from the Ministry of Education and Science to build more complex applications in VR technology for educational and training purposes. The main goal of the project is to develop and implement an innovative platform for cognitive training using virtual technology and augmented reality for a virtual laboratory of electrical power devices. As a result of the project, an innovative application will be created using VR technology and intended for learning the construction and operation of, among others, medium voltage switchgears, and an application for mobile devices using AR technology, which can be used both for learning and can support the work of construction managers and inspectors in a comprehensive way with the advantages of augmented reality. In addition, thanks to the implementation of the project, there will be a groundbreaking qualitative change in teaching the construction of electrical power equipment, as well as a change in the approach to conducting laboratory classes. In addition, the implemented solution will simplify the inspection and the reporting process, which is an undoubted advantage in the process of digitalization of construction. Thank you for your attention, and I invite you to our laboratory in the Warsaw University of Technology.